In this video, we're going to be taking a closer look at factoring when you're trying to look for the greatest common factor. In general, you're going to be asked to factor lots of different types of examples. The very first step you're going to want to do is to take out that greatest common factor. It makes the whole work afterwards much more simple. And so, as you take a look at all these options, A through E, and this initial problem, when you're asked to factor this, all of these would be correct answers for a factored version. Right? But we want to be factoring completely, which means factor out as much as possible. And none of these factor out as much as possible, because if you look inside the parentheses, there's more that you can do. Right? And so we always want to do and factor out as much as we can. So if you look at option F, this is where the greatest common factor is, where you have a 12x that's pulled out of each of these two terms, and so you have x plus 2. A lot of students think of it as the reversal of your distributive property because you're pulling something out from each of your terms. So let's take a look at a couple examples. Here, if we start with 8x plus 8, we have two different terms, so it's a binomial. So the greatest common factor has to go into both of those terms. And so we take a look, you have an 8 and an 8 here. So you could reverse and pull out from your reversing your distributive property an 8. And so it would be out front. And what you'd be left with, if you pulled an 8 out front, then what you'd be left with is an x plus 1. And that would be your greatest common factor of an 8. If you have 3x squared plus 12x, okay, well now you have numbers and x's that look like it could come out of both of these terms. So think of them separately. So you have a 3 and a 12. And so if I were to pull something out from there, I'd say, well, I could pull a 3 out from both. But you also have an x squared and an x. And so I can't pull out an x squared, because this only has an x, but you can pull just an x out. And so your greatest common factor is 3x, and so 3x times x plus 4 would be your answer there. For question 3, same idea. I have numbers and x's in both terms. So I take a look, I have a negative 9 and a 45. So from there, what you could pull out from both would be a negative 9. You could also pull out a negative 9, you could also pull out a positive 9, but we would prefer that when we have our parentheses here, inside it is a positive. And you'll see that as we finish this. With the x cubed and the x squared, I can pull an x squared out of that. And now that I pulled a negative 9 out, then you're going to have just a positive x. And we like to have that first term inside the parentheses be positive, if possible. And so now we would have a negative here that we're going to pull out, or have left after we pulled out a negative 9, and be a negative 5 inside. So negative 9x squared is your greatest common factor. Take a look at question 4. It looks like I have numbers, I have x's, and I have y's now. So I've got 3 different things to handle. So if I take one at a time, it looks like I can pull a 6 out of this. So I have a 6 out front, because 6 comes out of 24 and 6. And for the x's, I've got x squared, but only x to the 1 here. And so that means I can only pull a 1x out. And then I have y cubed and y squared, so I can pull a y squared out of that. So what's left after you do so, I pull a 6 out of 24, I have a 4 left. X out of x squared, I have an x left. Y squared out of y cubed, I have 1y left. And it turns out I pulled all of this 6xy squared out front. So do remember that you do need to have a minus 1 inside there in order to get a negative of that stuff. So factoring that out, you still have a 1 left. Taking a look at our last 3 examples, I have a 3 and a 75. So I can pull a 3 out of both of those. I've got an x squared, but I don't have any x's in my second term, so I'm not going to be able to pull any of that out. But I do have a y in each term, and so I can pull a y out, and what you're left with is an x squared minus 25. Now that's your greatest common factor. X squared minus 25 can be factored more, so you're going to have to come back and look at that later. Let's continue with our greatest common factor work, though. As I take a look at this one, now I have a trinomial, so I have 3 terms. Same ideas apply. Take a look at your numbers, so 4, negative 20, and a positive 24. And then I have x cubed, x squared, and x. So for my numbers, it looks like I can pull out a 4. For my x's, it looks like I can pull out an x because there's an x to the first here. So I want to do that. And what you are left with then is an x squared and then you have a minus 5x, because this was a negative 20, and then plus 6 as your remaining factor. 4x is your greatest common factor. And then down below, looks like I have numbers, x's and y's again. So take a look at the numbers, so negative 10, 25, and 60. And then you have x squared and x, but no x's in the last term, so that means we can't factor into that out. And I have a y in each. So as far as my my numbers are concerned in red, I can pull out a negative 5, because we want inside that parenthesis the first term to be positive when possible. And it looks like I can pull out a y, but no x's. So what you're left with then is a 2x squared, and then I pulled a negative 5 out of a positive 25, so that leaves me a negative 5x, and a negative 5 out of a positive 60, which means I have a negative 12. This is ideal here because we want our first term inside those parentheses to be positive. It just makes our other mathematics easier. So that's why we pull out a negative 5y for your greatest common factor. So in all of these, you're looking for what goes into each term. Be careful with these last three, number 5, 6, and 7, because what's left here after all that factoring, what's left can be factored further. So you do need to do that, which will come in our next videos. Good luck.